Welcome to my guide to the AP Calculus BC FRQ number 6 2008. I'm Sai Gantla from Mr. Happ's second period. Before we go into the question and the rest of the presentation, let's take a look at the scoring statistics for the 2008 FRQs released by College Board. As we can see, America on average did worse on question number 6 than they did on the other questions. This is mainly because question number 6 usually involves Taylor polynomials, or Taylor series, and this year was not an exception to that. Also, this year it integrated a ton of different concepts together, which was confusing to understand and is probably the reason why the average was lower for this question. Let's get into the format and the grading for the 2017 exam. So there's differences from the other years. This year the format will be 6 FRQs, 9 points each FRQ. The first 2 FRQs will be calculator. Your proctors will stop you there. The last 4 will be non-calculator. And so you'll know the proctors will give you 30 minutes for the first 2 calculator and 60 minutes for the last 4 non-calculators. So each question has multiple parts, around 3 to 4 parts, so you can get partial credit. There's no double, they don't double penalize you, which means that even if you get question A wrong and you needed the answer to question A to get question B, as long as you use your wrong answer from question A and do the rest of question B correct, they'll still give you full credit on question B. They'll only penalize you on part A. So the points distribution is as such. The MC is 50% of it, and the FRQs are 50% of it. The non-calc as a whole is worth twice as much as the calc. Now let's get on to the problem. So this is the 2008 number 6 FRQ. It was non-calculator. The first thing you want to do when looking at any FRQ is to understand what concepts you're going to be using in solving the whole question. So this one integrated a ton of concepts. There was logistic growth, differential equations, slope fields, Euler's method, and Taylor polynomials, Taylor series. So that's part of the reason why people got so tripped up and why the average was so low, because it's confusing to integrate all of these concepts together, obviously. So let's get into 6a. It says a slope field for the differential equation is given below. Sketch possible solution curves through the points 3, 2 and 0, 8. College Board was nice enough to give us the points. They also said draw in the slope field that they give you in the exam booklet. So when you're doing this problem, you want to follow the instructions. When you're doing every FRQ, you want to follow the instructions as much as you can. I don't know if they would take off points if you drew your own solution, your own slope field, and drew your own solution curves onto that. But I would try to follow the instructions as much as you can, because in the end, it's up to the discretion of the grader that you get as to how many points you're going to receive, whether or not they're going to take off points. This question's pretty simple. You're just going to follow the graph through these points that they give you, and your solution curves should really mirror the slopes that are present on this slope field, which are the slopes of the line segments. In order to solve this question, you kind of just have to have an eye for patterns, and you need to have some creative thinking. I'll put some practice problems if you really just want to get better at it. So that's what it looks like, as I showed earlier. You don't really want to you want to go through the same line segments that they have. Again, like, it depends on the discretion of the grader as to how much within a margin of error they're going to accept, but you want it to roughly look like this. It was 1 point per solution curve, so 2 point total for this question, 2 out of 9, or for this part of the question, so 2 out of 9 points. Now let's get into 6b. It says use Euler's method with 2 steps. That's the first thing you need to recognize, that you're using 2 steps to approximate f of 1. So this question might seem a little simple at first. It's a bit more involved than you would think. So the first thing to recognize is what is f. Because what they gave you was a solution curve, but you need to recognize what is f on that solution curve. Or on that slope field. Sorry, not solution curve, slope field. So they told us in the question that the solution curve that runs through f of 0 is equal to 8, so 0, 8 is f. So therefore, the solution curve at the top of the slope field that we were looking at earlier is f. So how can we calculate slope? Using the differential equation that they gave us. So again, the reason why it's so important for them to have given us this the fact that the solution curve that runs through 0, 8 is f is that for this slope field, for these 2 solution curves, they run these x values all have 2 various y values associated with them. That means that since they specified it's the solution curve on the top, you only use the y values from this top solution curve. So this is just a straightforward Euler's method. After that, you plug in y is equal to 8, because at 0, your value of y is 8 on that solution curve into this, and then you get that your slope is equal to -2. You plug in 1/2 because you're using 2 steps, so you're going to be at 0, 1/2, and 1. And then you add 8, because that's the y-intercept, which is equal to 7. And then to find f of 1, you just take 7 and you add it to 1/2 times -7 over 8. This -7 over 8 is the slope that you get when you put in 7 into here, into this dy over dt. And then 1 over 5 over 16 is your value for f of 1. The grading, the scoring rubric for this question was 1 point for the Euler's method using 2 steps, and 1 point for the correct approximation of f of 1. 6c, write the second degree Taylor polynomial for f about t equals 0 and use it to approximate f of 1. So this, I know I said that the Taylor polynomial is the harder part of the question, usually for most of America, but in this case, this one was not very hard. The first thing you need to ask yourself is how long should the polynomial be? So they say it's second degree, a second degree Taylor polynomial, which means you should have third terms. You should have a 0 degree, first degree, and second degree term. So that means that you'll need to go to the second derivative of f. So you find d squared y over dt squared, which is basically just taking the derivative of that differential equation that they gave you previously. Once you take that, you should get this second derivative equation. Then you find the first derivative of 0 of f of 0, or the 0th derivative of f of 0, the first derivative, the first degree derivative of f of 0, and the second degree derivative of f of 0. You use these as the coefficients for each of your terms, and you should reach a second degree Taylor polynomial here. The scoring guidelines simplify it a bit. Basically, this 4 is 2, the 2 from here, times 2 factorial. There's a 1 factorial under this 2t. There is a 0 factorial under this 8, and there's a t to the power of 0 multiplied by this 8. Also, you need to remember that they're asking you also to approximate f of 1. In order to do that, you just plug in 1 into this Taylor polynomial. You get 29 over 4. The scoring breakdown for this question was 2 points for taking the second degree derivative and understanding that you need to do that and taking it correctly, finding the second degree Taylor polynomial, and correctly approximating f of 1. Then D asks you, what's the range of f for t is more than or equal to 0? So first, what is f? Again, f is the solution curve that runs through 0, 8 on the slope field. It's this slope field up here. Then ask, where is f? Again, it's the solution curve up here on the slope field. And then, what are the bounds? So the bounds for f, and so one of them is t is more than or equal to 0, so we only look to the right of the y-axis, and then also what y values it falls between. As we can see, it falls between the y values of 6 and 8. The next thing we need to ask ourselves is it inclusive of 6 and 8? Well, it says t could be equal to 0, so at 0 we see that there is a point at y is equal to 8, so it's less than or equal to 8. However, there's an asymptote at y is equal to 6, so we will never have the value y is equal to 6. We will only continuously approach it. We will never actually reach it. So therefore, it's just more than 6, not more than or equal to 6. So, as you can see, the range of f for t is more than or equal to 0 is y is more than 6 and less than or equal to 8. The scoring breakdown is just 1 point for getting the correct answer, getting the correct range. It's a very straightforward question, and you should be able to get this question correct pretty easily. There's no work really that you need to show. You just kind of need to look at it and then just tell them the answer. So thanks for watching this. I will put practice problems for you to do in the description, and I will list how difficult they are, how relevant they are to these various topics. If you need any help with any of the topics listed in this video, good luck on the exam, and I hope this helped you guys. Thanks for watching.